So, in finding these roots, you guys have been, in the past, given one of the roots to start with to factor. In this particular case, you weren't given any of the roots. So what I'm going to do, and I'm going to do this with the calculator instead of Desmos, which is not totally my favorite, but it'll work. So I'm just going to put the 6x to the third minus 5x squared minus 19x plus 10 and graph. This is zoomed in quite a bit, but you can see we have one root at -1. So if I zoom 6 that and go to a normal 10 by 10. Oh, I was zoomed in the wrong place. No, we have, I need to zoom in a bit. So this is a lot easier to see on Desmos, but we have one root that's that's a clear root at 2. So we have one root at 2. Yep. So if we have a root at 2, somebody tell me what the factor is for that root. X minus 2. So using the boxes, this is one way we know to factor. Using the boxes, we're going to put our factor x minus 2. Oh, I suppose we should sketch this.
Are we going to have to know how to graph it in the calculator? Because that's where I got lost. I mean, I can like pull it up, but I can't get the x.
I actually got y equals 0, x equals 1.9.
Back to it. So the graph looked something like this. It did pass through 2. That was the one root we were certain of. Going much higher and much lower, but I don't really care about that. So to factor this, we start with our first term here. That's 6x to the third. And we factor, multiply from there. So if I know that this is 6x to the third, what do I know about this? No? What do I multiply by x to get 6x to the third? 6x squared. And then I multiply 6x squared by -2 to get -12x squared. Now, how do I figure out what this is going to be?
Oh, wait.
7x squared. That'd be -5.
So it has to, my x squareds have to add up to -5x squared. So I have to add 7x squared to -12 to get there. So from there I factor out a 7x, and then I multiply for a -14x. Because x times 7x will give me the 7x squared. So then -14 and something have to add up to be -19, -5x, factor out a -5, and then you always want to double check that your last two, -5 times -2, give you that last number. So from there, we want to factor the 6x squared plus 7x minus 5. So 6x squared, -5, and this is just box and diamond from there. Multiply the first and the last term to get -30x squared. I'm using this, by the way, for my new factoring thing. 7x for my middle term. My factors of 30 are 1 and 30, 2 and 15, 3 and 10, 5 and 6. So if my top number is negative and my bottom number is positive, what do I know about my side numbers? One of them has to be negative, and if my bottom number is positive, is that going to be my smaller or larger? Smaller. So what pair am I going to use? 10 and -3. So now I need to look at my greatest common factor. What is the greatest common factor for negative 3x and 6x squared? 3x. What do I multiply 3x by to get 6x squared? 2x. What do I multiply 3x by to get negative 3x? Negative 1. And then over here, 5. 5 times negative 1 is negative 5, so I'm good to go there. So, my fully factored form, which I don't have a line for, is x minus 2 times 2x minus 1 times 3x plus 5. And if I set each of those equal to 0 to give me my roots, I end up with 2 from my x minus 2, 1/2 from my 2x minus 1, and negative 5/3. So I'll show you guys, for those of you who didn't see that right away, like if I set 3x minus 5 equal to, plus 5 equal to 0, I subtract 5 from both sides. I'm just using the zero product property here. Divide both sides by 3, and I have x equals negative 5/3. That's how I got those roots. So, when we use a factor box, we're dividing the polynomial, all this whole thing. 6x to the third minus 5x squared minus 19x plus 10 by the known factor, which was in this case x minus 2. And the polynomial divides exactly, giving us the quotient 6x squared plus 7x minus 5.
Why did it make us find the root and then solve? Because if we're finding the root from a graph, can't we?
Okay, with long division, based on our root of 2, we have the factor of x minus 2, so we are literally dividing our polynomial by x minus 2. So, we start up here. So 6x to the third divided by x gives us 6x squared.
Why aren't we doing the negative 2 part?
We'll get there. We do it when we multiply. Oh, I know. Guys, just watch. Just wait. Write it down. If this isn't your preferred method, that's fine. So, then we multiply 6x squared times x gives us 6x to the third. 6x squared times negative 2 gives us negative 12x squared. So we multiplied our 6x squared by both of those terms. Now we're going to subtract. 6x squared times negative 2. So this times this gave me that. Now we subtract. 6x to the third minus 6x to the third is 0. This is where you have to be careful. Negative 5x squared minus a negative 12x squared gives us what? 7x squared. Because a minus a negative is going to make it plus. So that's 7x squared. How many times does x go into 7x squared? 7x. So this is going to be plus 7x. And we drop down that minus 19x and multiply again. 7x times x.
Why aren't we seeing how many times negative 2 goes into 7x?
Because we take care of the negative 2 part when we multiply. Just stick with me. Just stick with me. Then we do the 7x times negative 2, which gives us negative 14x.
Oh, okay.
Then we subtract again. So negative 19, this is a negative. Because negative 19x plus 14x would give us negative 5x. So we put the negative 5 up here. Drop down this plus 10. Negative 19x plus 14x gave us a negative 5x. Negative 5x divided by x gives us negative 5. And we multiply again, negative 5 times x.
Wait, negative 19x plus negative 14x.
Plus 14x. Negative 5 times negative 2 is positive 10. If we subtract those, we get a remainder of 0. The reason that you want to be able to do one of these two methods is so that you can find a remainder when something is not divisible by a factor. So, we're going to do the synthetic one in a moment. For the synthetic division, which I personally find a lot easier, you use the root. That is your root. And what you put here are your coefficients from your polynomial. Now, here's what you have to be careful about. So I'm going to write this above. Our 6x to the third minus 5x squared minus 19x plus 10. You have to have something for every degree. So this has to be 3, 2, 1, 0. If you're missing any of them, you need a placeholder. So I can do another one like that later. Yeah, you would just put 0 in for your coefficient. So for my coefficients, I'm putting 6, negative 5, negative 19, and 10. Now, if you're trying to get this to mathematically make a whole lot of sense, it's not going to work that well. But in terms of doing something really, really easily, if you can remember this process, it's a much easier process. So, put a line, drop down your 6. Multiply 2 by 6, put it there. And then you add negative 5 plus 12 gives you 7. Multiply again. 2 times 7 gives you 14.
This is literally the same thing, but there's just no x.
Why didn't we do it like this with arrows last time? Because that...
Negative 19 plus 14. Negative 5. 2 times negative 5 is negative 10 with a remainder of 0.
What? Miss Andrews, this is so much easier.
So, what you divide out here, guys, what you divide out here are your coefficients for your other factors. So our first factor was that x minus 2, and this is going to be 6x squared plus 7x minus 5. So the way that you know what this is going to be one less than your original degree, because you have to account for all those degrees in between.
So do you...
That brings us to the remainder theorem. What we just did, guys, what we just divided out, and we already wrote this up here, had no remainder. So as you may or may not recall from like long division, if you did it way back when, sometimes it doesn't go in evenly. It's like 5 doesn't go into 52 evenly. It goes in 10 times with a remainder of 2. So when we're dealing with polynomials, we may have a remainder if a factor is not a factor of our polynomial. So turn your paper over. And then I'm going to end this video because it's already 15 minutes long.